Hello there, everybody. We are the two mathematicians, and today we'll be going through the proof of 2 equals 1, and we'll be giving our opinions on it and why we believe that this cannot happen in maths. So I'm going to hand over to the other mathematician, and he's going to explain the proof.
Okay, yeah. So suppose we have some number a. We're just going to call it a, and let's let it equal to some number b. So a and b just representing a number, and they're the same number because they're equal to each other. So if we say a squared, well, a squared is just a times b because a and b are the same. So a times a is just a times b. Now let's subtract b squared from both sides. So we have a squared minus b squared equals ab minus b squared. With me so far?
Yep, that's all good.
Yep, and we can notice this here on the left, this is the difference of two squares. So we know that that factorizes to a plus b times a minus b. And then similarly on the right, we can factorize out the b, and we get b, a minus b. Okay, well, you can see we have a common term of a minus b on both sides, so we can just cancel them, and that leaves us with a plus b equals b. Okay, now because a is just b, remember, in the first one we just said a is b, we can say that b plus b equals b. So 2b equals b, and now dividing both sides by b, we get that 2 equals 1. As has been shown.
Yeah, it's a very cool formula and cool proof, but obviously in maths you can't have 2 equals 1, because then you could say 5 equals 4 or 6 equals 7. You can just keep adding numbers to both sides, and the whole function of maths just goes out the window.
Exactly.
So
yeah, I mean, with this you can say that anything equals anything else, really, which is
because if you just add 5 to both sides, then you have 7 equals 6, and we know
exactly.
that's obviously not true. And then you can square both.
But I've just shown it's true. Why don't you think it's true?
Well, the problem here is that if we look at the first line, we can see that a equals b. So obviously a minus b is the same as 0. I'm just going to write that down. A minus b equals 0. And if we look at line 4, we have a plus b times a minus b equals b, a minus b. And in order to cancel out the two a minus b's, we have to divide by a minus b. And obviously, we just said here that a minus b is 0. So we're saying that a plus b over 0. Sorry for my bad writing. We're dividing by zeros on both sides, and that cannot work, as you cannot be dividing by 0 in a place like this. So this is fundamentally why this proof does not work.
It's a big no-no. You can't divide by 0. This is the problem. This bit right there.
Yeah, and also I think if you look at the next line, a plus b equals b. If you minus b from both sides, then you have a equals 0.
And then you get a is 0 and b is also 0, and all sorts of weird things happen.
Big no-no.
No.
Okay, well,
I think it's a good proof because I think it's a good proof because it's quite simple and it fools people into thinking it's true. But obviously, there's this step that you can't forget.
Yeah, because when you're cancelling out a minus b, you're just cancelling out. You're not thinking, oh, you're dividing both sides by a minus b.
Because they're different letters, but they represent the same number, so you can't really do it.
Yeah, this is a good clickbait kind of thing. If you see on YouTube 2 equals 1, watch this video and you know that's not true.
And we've just shown that.
Yeah. So yeah, thank you for watching and taking the time to watch this. And if anyone comes to you saying 2 equals 1, show them this, and yeah, you'll be on the right path. So,
and remember, maths is the way.
Yeah, maths is the way. And have a great day. Bye.